For decades, writing software meant manually typing out every single line of logic. Over the last few years, AI stepped into the workflow, giving us tools that autocomplete chunks of code or write quick scripts on demand. That led to what the industry calls vibe coding. You give an AI a loose, natural language prompt, and it spits back a functional snippet of code. It feels fast, and for isolated tasks, it works well. But scaling that approach reveals a hard limit. When you apply unstructured prompts to a massive multi-file enterprise codebase, the AI loses the plot. Without explicit rules, the AI hallucinates logic. It breaks architectural dependencies across different files, and it leaves you with a tangled mess of decision-making that no human engineer can easily trace or debug. This brings us to a distinct shift in how we build software: agentic spec-driven development. AWS built Kiro to handle this. It treats AI as an autonomous agent you orchestrate, rather than a simple autocomplete feature. Generating code quickly without a structured architectural foundation doesn't yield viable software. It just generates technical debt at a much faster rate. This chart tracks development speed on the vertical axis against the growing complexity of an application on the horizontal axis. Looking at traditional manual coding, the trajectory is highly predictable, but as you can see, the velocity remains inherently low. When we map unstructured vibe coding, we get a massive initial spike in speed. You get a working prototype immediately. But as the application grows, that speed hits a wall and plummets because the AI cannot manage the structural weight. Kiro's spec-driven approach maps out differently. It starts a bit slower because you have to plan up front, but the trajectory stays consistent and scales with your application as complexity increases. Trading that chaotic, immediate burst of speed for a rigid, spec-driven foundation is the required trade-off if you want an application to scale in production. In a standard workflow, you drop an idea into a chat box and hope the AI guesses your intent. Kiro pauses the process to gather strict requirements first. This diagram shows how Kiro uses ears notation. It takes your natural language prompt and breaks it down into explicit technical constraints and acceptance criteria before a single line of code is written. From there, the agent analyzes the requirements and outputs a full system design and tech stack definition based on current best practices. Finally, it generates a strict implementation plan. The work is divided into discrete tasks, sequenced entirely based on their structural dependencies. Now, the trade-off here is entirely mental. As a developer, you have to resist the urge to start typing and instead spend time explicitly defining your constraints. Taking the time to lock down your intent up front removes the hours you usually spend downstream debugging code the AI hallucinated. Trying to describe a spatial layout or a user interface using only text is inefficient and highly prone to misinterpretation. Kiro is built with multimodal inputs. You can take a photo of a messy whiteboard session or a UI mockup, drop it into the chat, and Kiro uses it as the source material. The agent reads the visual context, maps out the spatial relationships, and instantly drafts the underlying logic and component structures for you. The catch is straightforward. The accuracy of the resulting code is strictly limited by how clearly you drew the initial sketch or whiteboard diagram. Skipping the manual translation of a visual design into a text prompt closes the gap between planning a feature and engineering it. Writing unit tests, maintaining project documentation, and formatting code are mandatory chores. But doing them manually constantly pulls developers out of their flow state. Kiro specifically addresses this with agent hooks, configurable triggers that launch autonomous agents to run entirely in the background. This diagram maps out a developer's workflow. On the top lane, you are actively coding a feature. The bottom lane represents dormant background capacity. The moment you hit save on the top lane, the agent hooks trigger. Down below, parallel processes instantly begin writing your unit tests and updating the project documentation based on your latest changes. Handing off these responsibilities means you have to trust the AI's autonomous outputs to meet your project standards without constant manual review. Delegating repetitive boilerplate to background agents lets a single engineer maintain high velocity while achieving enterprise-grade test and documentation coverage. For enterprise architects, the biggest barrier to adopting AI is data security. Sending proprietary codebases to public LLMs violates internal privacy rules. This diagram illustrates Kiro's privacy-first architecture. It creates an isolated environment, utilizing local execution and customizable steering files that define the coding standards without exposing your data to the public internet. When the AI needs access to internal databases or APIs, Kiro uses the Model Context Protocol. It securely connects the agent directly to your internal servers, keeping all data inside the company's perimeter. By controlling exactly where data flows, Kiro clears the compliance hurdles that keep frontier models out of large organizations. This flowchart breaks down your evaluation criteria. Choosing your development environment comes down to identifying your primary bottleneck. If your goal is generating ideas or throwing together a rapid, isolated prototype, standard unstructured AI chat workflows are the right tool for the job. But if you are scaling complex features across a large codebase or working under strict enterprise security requirements, an agentic spec-driven IDE like Kiro is required. This demands a mindset shift. You must stop viewing yourself as someone who writes logic line by line and start operating as an architect orchestrating autonomous systems. The highest return on investment in software development today is no longer typing faster. It is learning how to communicate your intent perfectly.